Hi everyone. So today's lecture is on psychometric chart. Psychometric chart is also known as psychrometric chart. So this is a chart which is used to explain the properties of moist air. Let's start with the definition of this chart by the basic funda that we always use, which is what, why and how of the particular word. So what is a chart? Chart is basically a graphical representation of all your data, and we have different types of charts. We have bar charts in which we use these bars. Then we have pie chart in which we demonstrate the data on the basis of a pie. Then we have a donut chart which looks something like this, and we represent certain values in form of a donut. What is the benefit of a chart? Suppose let's take an example. I have 10 chocolates, 10 maybe 20 toffees and 35 chips. So suppose I have this certain data. If I want to represent it in certain way, it will be like chocolate, toffee and chips. So if I have 10, 20, 30, 40 number on this side and my item on this side, then how can I represent my data here? So I have 10 chocolates in a bar form, it will be something like this. If I have 20 toffees, it will be like this, and if I have 35 chips, then it will be like this. Except of writing my data in a normal form, I am representing the same data in form of a bar chart. So this is something easy to understand, and many analysis can be done on the basis of this chart. So psychrometric chart, we can say, what is it? It is a graphical representation of the properties of moist air. So why do we do it? So that we can learn about the various conditions of the air, like temperature, humidity or heat inside the air. So moist air basically has two types of properties. One is thermal property and the other is physical property. And how is it done? It is done by analyzing the data and putting it in the form of a chart. So what does the definition of a psychometric chart become? Psychometric chart is a chart which graphically represents the properties of moist air, like its thermal and physical properties, air like humidity, temperature and heat, by analyzing the data and putting it in the form of a chart. Fine. Okay. Now, how does a psychometric chart look like? So in a chart, we have x-axis and y-axis. In the x-axis, we have temperature, and on the y-axis, we have humidity. Now let's say temperature is somewhere here and humidity is somewhere here. So it can be 10 degree, 20 degrees Celsius, 30 degrees Celsius, 40, and it can be 10%, 20%, 30%. So in psychrometric chart, there are certain values that we use. Now in temperature, there are two types of temperature that we use. First is dry bulb temperature, and then we have wet bulb temperature. We will discuss them later on in detail. And on this side, the humidity is actually relative humidity, which gives us the percentage of humidity in the air. Now, when we are calculating all these things in our chart, this helps us in getting a zone which is meant for the thermal comfort or the maximum comfort of a human being. So at last, what this chart is doing, it is giving us the analysis of the zone which is best suited for the comfort of a human being. Now let's start with the first component, which is called dry bulb temperature. discuss them both together, dry bulb temperature and wet bulb temperature. In general terms, if I say dry bulb temperature, this is the actual temperature of air. So this is something that you feel. The actual temperature of the air that you feel comes in your dry bulb temperature. Okay, so what is wet bulb temperature? In general terms, when your air can hold water vapors, suppose it has certain amount of water vapors in it, then there will be a certain extent of temperature up to which the temperature will drop down. Suppose in your actual temperature is 30 degrees Celsius, but your air has water vapors in it, then there is a certain drop in the temperature, and the maximum drop the air can take, that is known as the wet bulb temperature, in which you have humidity inside your air. So this is something that you feel, and wet bulb temperature is something when you feel when you are sweating. So how do we measure both of them? Suppose you have a thermometer and this is its wick. If you keep it normally at room temperature, it will give you the temperature of your room, which is suppose 35 degrees Celsius. Now in the same room, you are taking this thermometer and you are covering it with a cloth, and then you are putting it inside a beaker which is full of water. Now this represents that the maximum amount of temperature drop the air can take when it has water vapors inside it. So if this is 30 degrees Celsius, this might feel like 32 or maybe also 30 degrees Celsius. The minimum temperature till which the temperature can drop down, that is your wet bulb temperature. Now how they are measured? Both of them are measured in degrees Celsius or degree Fahrenheit. And in psychrometric chart, the dry bulb temperature is actually measured in the vertical direction like this. So if you have certain values, you can show your dry bulb temperature something like this, and the wet bulb temperature, it goes in the horizontal direction, something like this. And your relative humidity, it goes horizontally. We have certain comfortable zones for temperature, for humidity, like up till 26 degrees Celsius, it's comfortable for human being to stay in this temperature. You will neither feel too hot or too cold in this temperature. Humidity from 40 to 50% is appropriate for the human comfort. So when we find these values somewhere here, we get a zone which is for the maximum comfort level of a human being. So this zone becomes the comfort zone for a human being, and this is the main purpose of this chart. When we are getting temperature and relative humidity of a particular area, we try to find out the maximum comfort level of a human being according to given data. And with the help of the psychrometric chart, we can help in planning, and as for architects, we can have solutions related to energy efficiency in our building. With the help of this, we can design HVACs in particular area. If we know about all the data of the moist air, then we can design a centralized AC system according to it. Then while designing, before actually constructing your building, we can use certain passive cooling techniques in our building so as to come up with viable solutions for better thermal comfort of human beings. So dry bulb temperature is written as TDB, which is temperature of dry bulb temperature, and this is written as temperature WB, which is temperature at wet bulb temperature. Now, how does dry bulb temperature help us architecturally? In designing our outdoor areas, if we know what is the dry bulb or the actual temperature of the area, we can decide what type of material to be used, what type of conditions and what kind of design is to be made for your outdoor area, so that you can have good comfort level, not much of heat, not much of cold. Then we can also think about the materials that we need to use. If you have more of sun, you can block your sun inside your area if you don't want it. So dry bulb temperature will directly tell you what all measures to take at the time of designing the building. And as far as wet bulb temperature is concerned, it can help us in giving us solutions for natural ventilation potential in a particular building, so that we can have proper air inside the building so as to take the stale air outside, and passive cooling techniques, if we already know what can be the minimum amount of drop that we can get by putting up water bodies in that area, that can help, since wet bulb temperature will help us identify till how much level I can drop my temperature. If I can drop it up till 26 degrees Celsius, which is the maximum human comfort level, then I can obviously put a water body inside my proposal, so that except of using external resources for cooling down the temperature, we can have a natural way to cool it down. Now, the third type of value that we are getting in the psychrometric chart is relative humidity. Now, we studied about humidity. Humidity is the percentage of water vapor in your air. Now, what is relative? Relative is something that comes in comparison. Like in your studies, you have two type of assessments, cumulative assessment and relative assessment. In cumulative assessment, you get the percentage on the basis of, you get the grade on the basis of how much percentage you have got. But in relative assessment system, what happens, suppose the topper of the class has 60 out of 100, since he is the highest, he'll get A, then relatively according to him, the grade pattern will be set up. So the person who is getting 50 on 100, he might get B. So this system in education is known as relative, in which there is a comparison, and cumulative is the exact grading on the basis of your score. So relative humidity here is also something which we get in percentage by comparing it with the maximum amount of water vapor air can hold. So relative humidity becomes the actual water vapors in the air divided by maximum water vapors air can hold multiplied by 100. Once we multiply a value by 100, it becomes percentage. So relative humidity is the ratio of the current amount of water vapors that are present in the air to the maximum amount of it that it can hold. So this will give you the actual percentage of humidity inside that air. Fine. So what is the architectural relevance of relative humidity? We can help in determining the dampness that we get in an area, and we can give the solutions for it. For example, giving a DPC layer, or maybe we can have some solutions regarding the fungal growth, because the area which will have more of humidity, it will have a tendency to get dampness and fungal growth inside your building due to much of water present on the external face of your building, which can lead to poor indoor quality, and this can indirectly affect the health of the human beings inside it. So the areas which has more of humidity, we need to come up with certain solutions that can deal with dampness, fungal growth, and poor indoor quality. So yeah, these are the three values that are used in psychrometric chart. Other than these three values, we have two more terms that you should know, and one of them is dew point temperature. Now, what is a dew? Dew is something that you see over your grass when you wake up in the morning, and if early in morning you wake up when even the sun is not even rising, you see so small droplets on your grass and sometimes on your plants. Those are called dew. So dew is basically a water droplet when the level at which the water vapors, they start condensing and convert into a droplet. Water vapors turn into a droplet, or you can call it a dew. That point is called dew point temperature, because there will be a certain time when your air is holding water vapors. Then we call it, there is moisture in the air, there is dampness in the air. But a time will come when it will reach its saturation level, and after this saturation level, this moist air will convert itself into a water droplet, which will be called as dew. And that point where it breaks, that saturation point is known as dew point temperature. So how we can have its definition? Dew point temperature is the temperature at which air becomes saturated and the water vapors start to condense to convert into liquid. Your water vapor will start to condense, and the process of condensation will turn it into a liquid dew. Fine. So the higher the dew point temperature, the more moisture will the air contain. So high dew point temperature, high moisture in the air. So what is the architectural relevance of dew point temperature? Dew point temperature helps in calculating the moisture inside our basements, because basements are certain areas which are externally covered with earth, and earth will always have moisture content or water content inside it. So there is always a chance of dampness coming inside your basement. Usually we have cars parked inside the basement. We have car parkings in the basement. So for these area, we need to put up certain solutions like strong DPC, strong reinforcement, which does not allow this dampness to go inside your building, because dampness will ultimately lead in the deterioration of your walls, which can weaken the bonds of the walls, and then again fungus and indoor bad quality of air. So everything, if the moisture comes inside your basement, all these things will develop. So knowing the dew point temperature will help us in giving up certain solutions in the basements, even in bathrooms also, because bathroom also has more of water content inside it. So we can have certain thermal insulations inside these areas, or maybe dehumidifiers, which helps in taking out the dampness from the air, and at last certain moisture barriers can be installed like your DPCs, etc., which can avoid these areas to get affected. Fine. So how does these three values in the family work? Dry bulb is your actual temperature. Then dry bulb is the actual temperature of the air. When you have water inside the air, it will drop down to certain level and it will be called as wet bulb temperature. In dry bulb temperature, we don't have any water, so your wet bulb will have water, and in dew point, this water condenses into a water droplet or a dew. So the air starts with the dry air. From the dry bulb temperature, you get moisture, it's wet bulb temperature, and when it starts condensing into water droplets, it's dew point temperature. So this is the relationship between these three. Now the last point is enthalpy. Now what is enthalpy? Now we have talked in all the factors about the water content in your air. but we never talked about the heat content of the air. So enthalpy is basically the total heat content of the air, and the heat content of the air is measured by the sum of these two heat contents. First is called sensible heat and second one is called latent heat. Now, what is sensible heat? Sensible heat is the normal heat which we feel, which is felt as temperature. But latent heat is the heat that we feel due to the presence of moisture in the air. You might have seen in when we have the weather that we have during monsoons or after monsoons, what happens, you have certain heat in the air, but you also feel due to the presence of more moisture in the air, you feel more hotness. So that is known as latent heat, and sensible heat is the normal temperature. So what does the formula become? Enthalpy is termed as H. So enthalpy becomes the sum of sensible heat and the latent heat. So what is the function of enthalpy? It is crucial in designing HVAC for the building. What should be the size of the AC? And by doing the climatic analysis, we can suggest what type of HVAC should be installed. Then again, for ventilation and passive design, for putting up passive design strategies, we need to learn about enthalpy as well. Let's discuss one example. Suppose you have a room and the temperature of the room is 30 degrees Celsius and the relative humidity is 60 degrees. And in the same room, if you have 30 degrees Celsius temperature and 30% of relative humidity, which of these situations will have more of enthalpy? The answer is the more enthalpy will be in this room because of the more relative humidity. The more the latent heat, the more will be our total enthalpy. Since it is the total of both, if I have more latent heat, which means my humidity, 60% is more latent heat, 30% is less latent heat. So that means the enthalpy of this situation will be more as compared to this. Fine. So this is what we studied: enthalpy, dew bulb temperature, relative humidity, dry bulb temperature, and wet bulb temperature. The thing that we discussed about the human comfort level, let me explain this further. For dry bulb temperature, the maximum human comfort is between 20 degrees Celsius to 27 degrees Celsius, which becomes 68 degrees Fahrenheit to 81 degrees Fahrenheit. For wet bulb temperature, the maximum human comfort is 16 degrees Celsius to 22 degrees Celsius. Third is relative humidity. For relative humidity, 30 degree to 60 degree is the percentage which is ideal for our indoor range. This will be ideal for human comfort. Then dew point temperature, 10 degrees Celsius to 16 degrees Celsius, which is below your room temperature, and it is the maximum of human comfort that we can take in bedroom below room temperature. And the last one is enthalpy, 40 to 70 kilojoules.